Hey there, tech fans. Shano here. We're continuing in the flask.palletsprojects.com site, the Flaskr tutorial. We're on the 9th chapter. Test coverage is a pretty long chapter. We're not going to read all of the code in this one because it's just going to take too long. So test coverage. Writing unit tests for your application lets you check that the code you wrote works the way you expect. Flask provides a test client that simulates requests to the application and returns the response data. You should test as much of your code as possible. Code in functions only runs when the function is called, and code in branches, such as if blocks, only runs when the condition is met. You want to make sure that each function is tested with data that covers each branch. The closer you get to 100% coverage, the more comfortable you can be that making a change won't unexpectedly change other behavior. However, 100% coverage doesn't guarantee that your application doesn't have bugs. In particular, it doesn't test how the user interacts with the application in the browser. Despite this, test coverage is an important tool to use during development. Note, this is being introduced late in the tutorial, but in your future projects, you should test as you develop. You'll use PyTest and coverage packages to test and measure your code. Install them both. Run the pip install PyTest coverage command in the terminal. Setup and fixtures. Test code is located in the tests directory. This directory is next to the Flaskr package, not inside it. The conf test.py file in the test folder contains setup functions called fixtures that each test will use. The PyTest documentation has a description of what fixtures are. Software test fixtures initialize test functions. They provide a fixed baseline so that tests execute reliably and produce consistent, repeatable results. Initialization may set up services, state, or other operating environments. These are accessed by test functions through arguments. For each fixture used by a test function, there is typically a parameter named after the fixture in the test function's definition. Tests are in Python modules that start with test underscore, and each test function in those modules also starts with test underscore. Each test will create a new temporary database file and populate some data that will be used in the tests. Write a SQL file to insert that data. So now we have a data.sql file in the tests folder. It has the SQL command insert into user, then it has insert into post, and then the values at the end of the data.sql file. The app fixture will call the factory and pass test underscore config to configure the application and database for testing instead of using your local development configuration. Test underscore config is in the test underscore factory.py file, and there's two assertions there. So now we have the conf.test.py file. There's a with open os.path.join. It's going to pass a bunch of parameters. So there's a PyTest fixture for the app function, for the client function, and then there's a runner function. Tempfile.mkstemp function creates and opens a temporary file, returning the file descriptor and the path to it. The database path is overridden, so it points to this temporary path instead of the instance folder. After setting the path, the database tables are created and the test data is inserted. After the test is over, the temporary file is closed and removed. Testing tells Flask that the app is in test mode. Flask changes some internal behavior so it's easier to test, and other extensions can also use the flag to make testing them easier. The client fixture calls app.test underscore client function with the application object created by the app fixture. Tests will use the client to make requests to the application without running the server. The runner fixture is similar to client. App.test underscore CLI underscore runner function creates a runner that can call the click commands registered with the application. PyTest uses fixtures by matching their function names to the names of arguments in the test functions. For example, the test underscore hello function you'll write next takes a client argument. PyTest matches that with the client fixture function, calls it, and passes the returned value to the test function. Factory. There's not much to test about the factory itself. Most of the code will be executed for each test already, so if something fails, the other tests will notice. The only behavior that can change is passing test config. If config is not passed, there should be some default configuration, otherwise the configuration should be overridden. Then we have the test underscore factory.py file. We define the test underscore config function, and we define a test underscore hello function. You added the hello route as an example when writing the factory at the beginning of the tutorial. It returns hello world, so the test checks that the response data matches. Database. Within an application context, get_db should return the same connection each time it's called. After the context, the connection should be closed. Now we have the test_db.py file in the tests folder, and then we define the test_get_close_db function. The init-db command should call the init_db function and output a message. Next we have the test_db.py file, and we define the test_init_db_ command. We pass it a runner and monkey patch. This test uses PyTest's monkey patch fixture to replace the init_db function with one that records that it's been called. The runner fixture you wrote above is used to call the init-db command by name. Authentication. For most of the use, a user needs to be logged in. The easiest way to do this in tests is to make a POST request to the login view with the client. Rather than writing that out every time, you can write a class with methods to do that and use a fixture to pass it the client for each test. So we're in the conf test.py file in the test folder, and there we have a class, auth actions. We pass it an object. We defined a dunder init, and we define a login function. First parameter self, second parameter username equals string test, third parameter password equals string test. Then we define the logout function. It's passed self, and then that returns self._client.get. We pass that /auth/logout. Then we have a fixture. We define the auth function, we pass it to client, and we return auth auctions, and we pass that client. With the auth fixture, you can call auth.login function in a test to log in as the test user, which was inserted as part of the test data in the app fixture. The register view should render successfully on get. On post with valid form data, it should redirect to the login URL, and the user's data should be in the database. Invalid data should display error messages. So now we're in the test_auth.py file. We define a test_register function. Then we have another decorator at pytest.mark.parameterize. And there we pass a username, a password, a message. Then we define the test_register validate_input function. Client.get function makes a GET request and returns the response object returned by Flaskr. Similarly, client.post function makes a POST request, converting the data dict into form data. To test that the page renders successfully, a simple request is made and checked for a 200 OK status code. If rendering failed, Flaskr would return a 500 internal server error code. Headers. Headers will have a location header with the login URL when the register view redirects to the login view. Data. Data contains the body of the response as bytes. If you expect a certain value to render on the page, check that it's in data. Bytes must be compared to bytes. If you want to compare text, use get_data function and pass it as_text equals true instead. pytest.mark.parameterize tells PyTest to run the same test function with different arguments. You use it here to test different invalid input and error messages without writing the same code 3 times. The tests for the login view are very similar to those for register. Rather than testing the data in the database, session should have user_ID set after logging in. So then we're back in the test_auth.py file in the tests folder, and we define a test_login function, and then we have a decorator pytest.mark.parameterize function. Then we define a test_login_validate_input function that ends test_auth.py. Using client in a with block allows accessing context variables such as session after the response is returned. Normally, accessing session outside of a request would raise an error. Testing logout is the opposite of login. Session should not contain user_ID after logging out. So there's another addition to the test_auth.py file. We're defining the test_logout function. Blog. All the blog views use the auth fixture you wrote earlier. Call auth.login function, and subsequent requests from the client will be logged in as the test user. The index view should display information about the post that was added with the test data. When logged in as the author, there should be a link to edit the post. You can also test some more authentication behavior while testing the index view. When not logged in, Each page shows links to log in or register. When logged in, there's a link to log out. Now we're in the test_blog.py file. We're going to define a function, test_index. We're going to pass it a client and auth. Then we have the auth.login function. A user must be logged in to access the create, update, and delete views. The logged in user must be the author of the post to access, update, and delete. Otherwise, a 403 forbidden status is returned. If a post with the given ID doesn't exist, update and delete should return 404, not found. So now we're in the test_blog.py file, and we're going to have a decorator pytest.mark.parameterize. Then we define a test_login_required function. We pass it client and path. We define a test_author_requires function. Then we have a decorator pytest.mark.parameterize. Then we define the test_exists_required function. The create and update views should render and return a 200 OK status for a GET request. When valid data is sent in a post request, create should insert the new post data into the database, and update should modify the existing data. Both pages should show an error message on invalid data. Then we have another change to test_blog.py. It defines the test_create function. It defines a test_update function, and there's a decorator at pytest.mark.parameterize. There's another function defined, test_create_update_validate. The delete view should redirect to the index URL, and the post should no longer exist in the database. The test_blog.py file, we're going to define the test_delete function. Running tests. Some extra configuration, which is not required but makes running tests with coverage less verbose, can be added to the project's pyproject.toml file. So we have the pyproject.toml file. In brackets, we have tool.pytest.ini_options. Next, we have another brackets with tool.coverage.run. To run the tests, use the pytest command. It will find and run all the test functions you've written. So we have in terminal command pytest. The result of that, the comment test session starts. And then it has a bunch of values for each of the tests. If any tests fail, pytest will show the error that was raised. You can run pytest-v to get a list of each test function rather than dots. To measure the code coverage of your tests, use the coverage command to run pytest instead of running it directly. So there we have a terminal command, coverage run -m pytest. You can either view a simple coverage report in the terminal, and then it has the terminal command coverage report, a table that shows up. The columns are name, STMTS, miss, branch, BR part, cover. An HTML report allows you to see which lines were covered in each file. And then there's a terminal command coverage HTML. This generates files in the HTML cove directory. Open htmlcove/index.html in your browser to see the report. And that ends the testing chapter. The next chapter will be deploy to production.